Good day everyone, welcome once again to our session. Today we are going to discuss the second example of rationalizing substitution. As mentioned before in our first example, the purpose here is to uh, change the irrational fraction into rational one. That's why we are going to do the U substitution. Okay, so we have here the given integral of, okay, so we have the integral of 1 divided by the cube root of x plus the square root of x. Okay, so our goal now is to convert, no, or we have to transform this into something that will make it a rational fraction, because this contains the radical, the cube root, and the square root. So this expression here is a irrational fraction. By the way, we have here dx. So to make this integrable, we have to complete. No, we should have a dx here. So I forget to write the dx. Okay, so now we know that the cube root of x, when you express this in terms of an exponent, that is rational exponent, so this will be x to the power, the cube root of x is just the cube root of x is just equal to x to the power 1/3, right? And the square root of x is just equal to x to the power 1/2. So now we are going to figure out what substitution that we can make, to transform this radicand into a rational expression or fraction. Okay, so if we let x, the best way here, because if you you know that this is the cube root, so the way to eliminate the fractional exponent here, so you have to have a perfect cube, right, for this one. So perfect cube meaning you have to raise this to power 3, so you have x. And similarly to this one, to eradicate this radical, the square root, so you have to raise this to power 2, or here x to the power 1/2 you raise to power 2, so that will be x. But how to do that? What is this exponent that is common to these two, 1/3 and 1/2? So that when we take the cube root of that expression, then we will get a whole number for the exponent. Okay, so if we let x be equal to, so 3 and 2 here, the common multiple here, or the common number, that is equal to 6, so we can let x be equal to u to the power 6. Okay, so that when you substitute x equal to u to the 6 here in this radical, for example here, so we have our x is equal to u to the 6, so meaning substituting x equal to u to the 6, so this will become the cube root of u to the 6, or this is the same as u to the 6 raised to a power, this one, 1/3. Or this is equal to u squared. Okay? And similarly for this, so substituting x equal to u to the 6, so change x to u to the 6. So square root of u to the 6, which is equal to u to the 6. So square root meaning 1/2, no, raised to power 1/2. So this is raised to power 1/2. So equal to u cube. Right? So from here, since we make a substitution that x equal to u to the 6 or u equal to the 6th root of x, and now let us express let us change our dx in terms of du. So from here, if we take the derivative of x or take the differential of x, take the differential on the left side, so you do the same on the right side. So using the power formula, power rule, so we have 6 u to the 5th, then times du. Okay? So that is our dx. 6 times u to the 5th times du. So if we're going to substitute all this here in our original integral, so from here, so equal to the integral of 1 divided by, so cube root of x, so our cube root of, or sorry, our dx, so we have here 1 times dx, our dx is equal to 6 times u to the 5th du. Then our cube root of x, so what is our cube root of x? Our cube root of x, which is equal to u squared, right? So this is cube root of x is equal to u squared. So this is u squared. Then plus the square root of x. So square root of x, which is equal to this one. That is u to the 3rd power. Okay, so this is now our resulting integral function. Okay, so 1 times this, so we have integral of 6 times u to the 5th du, then divided by u squared plus u cubed. And for the denominator, we can factor common in the denominator so that we can reduce, or we can simplify this one. And we have a constant, so we can put the constant on the left side of the integral sign. So we have to isolate the constant. So we have 6 times the integral of u to the 5th power du, then divided by common, which is u squared. So factoring out common, so we have 1 plus u. Okay, 1 plus u. So we have u to the 5th power at the numerator, and then we have u squared at the denominator, so we can factor out common, which is u squared. So what is left on the at the numerator, so our numerator becomes, so this becomes u cubed, okay, because we factor out already the u squared, du, then divided by 1 plus u. Okay, so if you look at now the result after our substitution, so we can say that this is an improper fraction. Improper because as you look at the degree at the numerator, so the degree at the numerator is higher than the degree at the denominator. So the degree here is equal to 3, all right? The degree here is understood to be u to the power 1, so the degree here is 1. All right? By the way, we can rewrite this as 6 times the integral of u cubed du. We can interchange the position of 1 and u. So divided by u plus 1. So they're just the same class. Okay? Now, as you can see from this, we cannot apply the integration of rational fraction yet. So we need to, because since this is an improper fraction, so we can use that technique only if the degree at the numerator is less than the degree at the denominator. But for the case where, or for the scenario where the degree at the numerator is equal to the degree at the denominator, or the degree at the numerator is higher than the degree at the denominator, so we have to do another procedure to solve that integral. Okay? So from here, since the degree at the numerator is higher, then we have to do the long division. So you can use the synthetic division, you can use the long division, or the polynomial division. Okay, so using the polynomial division, so we have, okay, I will show you how to do that here. So this is a topic in our algebra, or even in our elementary or high school, we have learned already how to do the long division. Okay, so we have here the numerator. So the numerator is u cubed. Okay, so numerator is u cubed. Then we divide this by u plus 1. U plus 1. So how to do the long division? It's just like u, the first term here is only one term here. We have two terms here. So first term divided by the first term. What is left? So what is left? So we have 1, right? So we have 1. So 1 times u. This is u. So u cubed divided by u, so that is u squared. Okay, so this is u squared. Okay, so u squared times u, that is u cubed. Then u squared times positive 1, so that is positive u squared. Okay, and then the rule here is after you do that, you have to subtract. So when you subtract, Okay, so it means you need to change the sign, then you add. Okay, or you just subtract. Use u cube minus u cube, so this is 0, and then this is understood to be 0 here. So 0 minus, so this is plus, so this becomes minus, so this becomes minus u squared. Okay, so can we still divide this one by our divisor? Yes, because the degree here is still higher than the degree of this divisor or denominator. Okay, so this is minus, so it means this is also minus here. Alright, so u squared divided by u, so u squared divided by u, that is equal to u. Alright, so u times u, that is u squared, minus u times positive u, so this is minus u squared. Then minus u times positive 1, so that is minus u. Okay, so again, we have to subtract. So when you subtract, so change the sign, then you add. Okay, so this is, when you subtract, so this becomes positive. Okay, so it's something like this. So when you subtract, this becomes positive. You combine, you add, so this becomes 0. This becomes positive. So again, this is understood to be, there's a 0 here. So 0 minus minus, so plus, so this is plus u. Okay, so can we still divide? Yes, because the degree of u here is the same as in the divisor or the denominator. So this is positive, so positive u divided by positive u, so this is positive 1. Okay, so 1 times u, that is equal to this positive 1. Positive 1 times positive u, that is positive u. Okay, then 1 times 1, they are both positive, so that is positive 1. Okay, then you subtract. So again, when you subtract, change the sign and then proceed to addition. So this becomes negative. When you add positive u and negative u, so it is 0. So this is again understood, there's a 0 here. So 0 minus, so this is plus, so this becomes minus. So 0 minus 1, so this is negative 1. Okay, so therefore, so going back here, so this becomes 6 times the integral of, so we have here the result of our long division. So you substitute it here in our integrand. So this will be u squared minus u, then plus 1, then minus, we have here the remainder. So this one class is the remainder. So this, when you combine it with this result, the quotient, then you have to divide it by its divisor, which is, so minus 1 divided by our divisor, which is u plus 1. And everything is multiplied by du. Okay? Then 6 is common to each of the term. So you can distribute 6, you can distribute the integral sign and also the du, so that this becomes 6 times u squared, integral of this, times du. Okay, then minus, distribute 6, distribute the integral sign, so you have 6 times the integral of u, then times du. Okay, then plus, we have 6 times 1, so that is 6 times the integral of du, then minus 6 times the integral of du over u plus 1 or 1 plus u. Okay? So here, there's no problem. We can easily integrate this using the power rule, power formula. And so do with this one. So using the basic formulas. Okay, and for this one, we can use the integral of du over u, which is equal to ln u plus c. Okay, so this is in the form of du over u. Alright, so, or if you want to let another variable, say, if you use dv, so dv over v, so this is ln v plus c. So for example, if you let v equal to u plus 1, so your dv is equal to du. So if you let v equal to u plus 1, then your dv is equal to du. So this is in the form of du over u, or dv over v. Okay, so using the power formula that we have learned before, so we have, so this will be 6 times u cubed divided by 3. Okay, then minus 6 times u squared over 2, then plus 6 times du, which is equal to u, 6u, then minus 6 times, this is ln of u plus 1, then plus c. Okay? Okay, I will use another board. So I just rewrite it here, class. So we have here 6. Okay, so we can reduce this one. So we have 6 divided by 3. Okay, so I will write it here. So 6 divided by 3 is equal to 2. So this will be 2u cubed. Alright, then minus 6 divided by 2, so 3 times u squared. So this is 3 times u squared, then plus 6u, then minus 6 times ln of u plus 1 plus c. Then substituting, so what is our u? So what is our u? So we have from here, okay, so our x equal to u to the 6. So from here we can solve for u in terms of x. So how to solve u in terms of x from here? So we have, if our x equal to u to the 6, then solving for u here, so you have to raise both sides by a power 1 over 6, right? So x raised to a power 1 over 6, do the same on the right side. U to the power 6, then raised to a power 1 over 6. So we have here, from here, so we have x to the 1 over 6 equal to 6 times 1 over 6 is equal to 1. So this is now our u. Okay, so substituting u to this equation, then we have 2 times u. Our u is x to the power 1/6. Then this one is raised to a power 3. Okay, so raised to a power 3. Then minus 3 times u. our u is equal to x to the power 1/6, then raised to a power 2, right? Raised to a power 2. Then plus 6 times u, which is x to the power 1/6. Okay? Then minus 6 times ln of u, where u is x to the power 1/6. Then plus 1. Then plus c. Okay? So 1/6 times 3. So what is 1/6 times 3? So that is 1/2. So this will be x to the power 1/2. Then minus 3 to the, or 3 times x to the, what is 1/6 times 2? So that is 1/3, right? So x to the power 1/3. Then plus, so the same, 6 times x to the 1/6. Then minus 6 ln x to the power 1/6 plus 1, then plus c. And then you can convert this in terms of radical. So we can rewrite this as 2 times the square root of x minus 3 times the cube root of x, then plus 6 times the 6th root of x, then minus 6 times ln of the 6th root of x plus 1, then plus c. So this is our final answer. Okay? Do you have any question? So hope that you're able to follow the steps, class. All right? So thank you very much, and hope to see you again in our next video, or our next example. Okay? Bye. Bye for now.